Good morning. Welcome to SAKALAVIDYA YouTube channel. So far, Shamala, Balu, Swati, Pavan Kumar, Tarun Sai, Prasanna Lakshmi, Yadav, Pavan, Vishwaveera, Vaibhav, Ishwar Chandra, Kirtana Kotla. Okay, Vaishnavi. Fine. Tirupati, Tanuja, Ishwar Chandra. Okay, Katlagunta Karthik. Good morning all. Once again. Vishwanath Dasika. Somasekar, Jishnu Chintu, Praveen Kumar Ketamreddy. So in the last session, up to 34 problems we have completed, I think so. Lakshman Donala, Perugu Ramya, Gaddam Nitin, am I audible and visible to you? Am I audible, visible to you? Swati Singh, yes, 36th question, correct. Okay, Bintu Reddy, Sivasai, wait Perugu Ramya, definitely hard questions. Today I will discuss last 5 minutes or 10 minutes I will discuss hard questions. Right. But not visible. But I may not be visible, but audible is enough. Tough questions. Evening class, no. Only 1 hour I will take. That's enough. So I will conduct the meeting. Definitely I will inform you. Fine. Tomorrow there will be class, but actually I have other sessions. So that's why it is tentative. So but definitely I'll get the notification. Don't worry. I will inform. You need to check our YouTube channel. I cannot decide that. Before day I cannot decide because that depends upon nature of the work. Fine, fine. Okay, leave it been ready. So good morning, good morning. So leave it WhatsApp group. I think in this time actually it's not required. Don't worry about that WhatsApp group. Just whenever class is there, you come, just watch and go. That's enough. P of A intersection B. Okay. I will try. I will try. Sarath Sai. Good morning, good morning. Formula I already completed in the first session. We have completed. Watch probability part 1. Good morning, Prasanna. A complement intersection B. That's A complement intersection B is B minus A. Suma, good morning, good morning. Thank you, thank you. What is meant by Vishwavira? What is that? Okay. So 1 minute. I will discuss the questions. Okay, 35th problem. 35th problem. 35th problem. If one ticket is randomly selected from tickets numbered from 1 to 30. That means 1 to 30 numbered cards are there. Then the probability, then the probability that the number on the ticket is a multiple of 5 or 7 is first option 1 upon 3, second option 1 upon 5, third option 5 upon 12, fourth option 1 upon 6. Right. All of you just note down the question and look at the screen. If one ticket is randomly selected from the tickets numbered from 1 to 30, that means there are 30 tickets, we need to select one ticket. So that can be done in 30 C1 ways. N of S is equal to 30 C1. Next, what we need to find out, second part of the problem, the probability that the number on the ticket is a multiple of 5 or 7. That means we need to collect multiples of 5, multiples of 7, and next this N of S is equal to 30. So that means actually this problem need to be done like this. 36th solution. N of S is equal to, out of 30 one need to be selected, so 30. Let A be the event of getting a multiple of 5. So what are the multiples now here of 5? 5, 10, 15 and dash 30. So here N of A equals to, you can write number of elements present in this set or number of sample points in this event. N of A is equal to, you can write like this, 30 minus 5 upon 5 plus 1, 7. There are N of A is equal to 7. Now next, sorry, 25, 6, this is 6, this is 6. 25 minus by 5 is 5, 5 plus 1 is 6. So now let B be the event of getting a multiple of 7. Therefore multiple of 7 means we can write B equals to, multiple of 7 means 7, 7 plus 14 dash up to 28. That means N of B equals to, you can write 28 minus 7 divided by 7 plus 1. 28 minus 7 is how much actually? 21 by 7 plus 1. 4 you will be getting. N of B is 4. Next, A intersection B is the event of getting multiple of multiple of both 3 and 7, that is LCM of 3 and 7, sorry, LCM of 5 and 7. LCM of 5 and 7 is 35. So it is 1 to 30 itself only. There will not be any multiples of 35. So that means A intersection B is equal to nothing, pi. That means they are mutually exclusive events. So what we need to find out now here, P of A union B you need to find out. That means either multiple of 5 or 7. P of A union B is equal to, you can write P of A plus P of B. P of A plus P of B equals to, here P of B means actually here see what do you write now, N of A by N of S 6 upon 30 plus P of B is equal to 4 upon 30. So that will be 10 upon 30. Answer is 1 upon 3. This is the answer, 1 upon 3. Right now, this is the problem. So now let us come to this one, shortcut. Let me explain the shortcut. What is the shortcut means? Directly we can write N of S is equal to 30 C1, that is 30. Okay. Now A be the multiple of A, B be the multiple of 7. Then what we need to find out? P of A union B we need to find out. Either A or B is equal to 30 divided by 5 integral part plus 30 divided by 7 integral part, now minus integral part of 30 divided by LCM of 5 and 7 upon this 30 right down. What is the integral part of 35 by 30 divided by 5 means quotient. When 30 divided by 5, what is the quotient? Quotient is 6 plus here 30 divided by 7 quotient is 4 minus 30 divided by 35. 30 divided by 35 is the, here actually you need to take 35. 30 divided by 35 is 0 upon 30. So 10 by 30 is 1 by 3. That means first option is the right option. First option is the right option. So I know the shortcut also. So this is the shortcut need to be done. So this is the method. This is the method. And this is the shortcut. As you wish, you can choose the method. Okay, 37. If A and B are two events such that P of A equals to 0.3, P of B equals to 0.6 and P of B conditioned on A equals to 0.5, then P of A conditioned on B. So actually this type of question, now this is conditional probability questions. First option 1 upon 2, second is 1 upon 3, third is 1 upon 4, fourth is 2 upon 3. Okay. So P of B conditioned on A given actually. See, A, B are two events such that P of A is equal to 0.3, P of B is equal to 0.6, P of B conditioned on A is equal to 0.5, then P of A conditioned on B we need to find out. See, in order to find out P of A conditioned on B, we need P of A intersection B. If we know the P of A intersection B upon P of B is our answer. So that means with the help of P of B conditioned on A and P of A, we need to find out P of A intersection B. First, let us find out, first step is to find P of A intersection B. See, P of A intersection B is multiplication theorem on probability. Using that concept, we can write P of A times P of B conditioned on A. So P of A equals to 0.3 times P of B conditioned on A, 0.5 is equal to 15, but 2 decimal points, 0.15. Now what we need to find out? P of A conditioned on B we need to find out. P of A conditioned on B means P of A intersection B upon P of B. This is by the definition of the conditional probability. So that is 0.15 upon P of B. P of B is 0.6, or this can be written 0.15 upon 0.60 also we can write. 15 upon 60. 15 1 ja, 15 4 ja. So 1 upon 4 is the answer. So Perugu Ramya asked such type of questions only. Are you there, Perugu Ramya? What about vectors? Okay. In Zoom classes, I will explain vector chapter. Right. $38. If A and B are any two events such that P of A equals to 0.3, P of B equal to 0.6, and P of B conditioned on A, or P of occurrence of B after the occurrence of A equals to 0.5, then P of A union B we need to find out. So first option 0.5, second option 0.65, third option 0.75, fourth option 0.85. First see, so what are given actually, read the question all of you. A comma B are any two events such that P of A is equal to 0.3, P of B is equal to 0.6, P of B conditioned on A is equal to 0.5. Then we need to find out P of A union B. So just if you see our target, our aim is P of A union B. If you want to find out P of A union B, we have the formula or theorem, addition theorem on probability, that states that P of A plus P of B minus P of A intersection B. We know P of A, P of B, but we do not know P of A intersection B. First let us find out P of A intersection B. So first let us find out P of A intersection B. See the P of A intersection B. So this can be evaluated using multiplication theorem on probability. So that can be written P of A times P of B conditioned on A. So this is P of A intersection B. So that equal to, we have 0.3 multiplied by 0.5 whose value is 0.15. So now we are able to find out P of required value, P of A union B. The P of A union B is equal to addition theorem, P of A plus P of B minus P of A intersection B. Substituting the respective values, 0.3 plus 0.6 minus 0.15. This is 0.9 minus 0.15. So now 0.90 we can write, subtract 0.15. So 7 point. So this equals to 0.75. This is the answer. So third one, 39. A and B are events such that P of A equal to 0.3, P of B equals to 0.25 and P of A intersection B is equal to 0.2. Then P of A bar conditioned on B bar equal to, first option 11/15, second 12/15, third 13/15, fourth 14/15. This is the question. Where is Perugu Ramya? A comma B are events such that P of A is equal to 0.3, P of B is equal to 0.25, P of A intersection B is equal to 0.2. So then we need to find out P of A bar conditioned on B bar we need to find out. So let us try. What do we get now? P of A bar conditioned on B bar as per the definition of the conditional probability or multiplication theorem. So this we can write conditional probability P of A bar intersection B bar upon P of B bar, you can write it. Here we have one interesting formula. This we can write P of A union B whole bar upon P of B bar. So this can be written 1 minus P of A union B upon this can be written 1 minus P of B. See, check. That means P of B is there, but we don't have P of A union B. Say this is equation 1 now. First let us find out P of A union B first. We need P of A union B value. P of A plus P of B minus P of A intersection B. Addition theorem. This can be evaluated 0.3 plus 0.25 minus 0.2. This will be 0.1 plus 0.25. Okay. Can it be 0.35? Can it be 0.35? So that means therefore now we need to find out required value. P of A bar conditioned on B bar is equal to, we can write 1 minus P of A and B. 1 minus 0.35 upon 1 minus P of B. That is 0.25. That is equal to 0.65 upon 0.75. That is 65 by 75. 13, 5, 15, 65. 65 means what do you get now here? 5 1 ja, 5 13 ja, next 5 15 ja. 13 by 15 is the answer. Okay, third option. So except this chapter, the remaining chapters I will discuss in the Zoom itself only. I will give the notification, password and ID before one day before. Two dice are rolled. Two dice are rolled at random. Simultaneously. And the sum of the numbers on them is 6. The probability of getting a number 4 on any one of the dice is first option is 1 upon 5, second option 2 upon 3, third option 1 upon 3, fourth option 2 upon 5. This is the question. Two dice are rolled at random. The sum of the numbers on them is 6. The probability of getting a number 4 on any one of the dice is. So that means what we need to find out means actually here already the sum of the numbers on them is 6. So let us say like this now. Let A be the event of getting a sum 6 on them. That means A is equal to possible chances we have like this: 1 comma 5, 2 comma 4, 3 comma 3, next 4 comma 2, next 5 comma 1. Okay, so next, what the probability of getting a number 4 on any one of the dice. That means after the occurrence of this sum 6, then the probable then event of getting 4 on any one of the dice occurs. So that means say B, that is B. Let B be the event of getting 4 on any one of them. That means B equals to, you can write like this. So that means either 2 comma 4, the 4 appears here, 4 comma 2, two chances. So that means in B you have 2 comma 4 and 4 comma 2. Now what we need to find out here, P of B conditioned on A. So P of B conditioned on A. P of B conditioned on A is equal to P of A intersection B upon P of A. That means this we can write N of A intersection B by N of A also we can write. See, N of A intersection B means both, this is the both, 2 comma 4, 4 comma 2, 2 comma 4, 4 comma 2. Here two chances we have. Here N of A means 1, 2, 3, 4, 5, 6 chances. So answer is equal to 1 upon 3. Third option is the right option. Third option is the right option. Sorry. Mistake. N of A is equal to 1, 2, 3, 4, 5. 2 by 5. Absolutely sorry. 2 by 5. Fourth option is the right option. Yes. Forty-one. Right, 41. Two integers are selected at random from integers 1 to 11 if the sum is even. If the sum is even, then the probability that then the probability that probability that both are odd, both are odd, the selected numbers must be odd and sum must be even, both are odd, both are odd is first option 6 upon 11, second one is 3 upon 5, third one is 2 upon 5, fourth one is 4 upon 5. Okay. See here, the two integers are selected at random from 1 to 11. If the sum is even, that means this event should occur. The sum is even. Then the probability that both are odd, this both must be odd, that we need to select. So that means, for example, solution right down here. Let A be the event of getting a sum, getting even sum. Even sum means, for example, you take two numbers here. You take two numbers. For example, A plus B equal to even number means here two cases will arise. Even plus even is equal to even, you get, or odd plus odd is equal to even, you will get it. These two cases. This is actually mutually exclusive events, these two. That means in order to get A plus B is equal to even, the first number must be even, second must be even, or first number must be odd, second number must be odd itself only. So that means favorable cases n of A, if you want to find out n of A, what you need to select means, so either you need to select two even numbers out of 11, or you need to select two odd numbers. So that means how many actually here odd numbers and even numbers in between 1 to 11, that we need to count. So that means actually 1 to 11 means, you check it now here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10, 8, 6, 4, 2. They are even. So that means how many even are there? 1, 2, 3, 4, 5. 5 even are there. Out of 5 you need to select 5C2. This is R. Here sense is R sense. Either one R. R means you need to take plus. Next, how many odd numbers are there? 11 minus 5. 6. 6C2. This is equal to 5C2 means 5 into 4 upon 2 into 1 plus 6C2 means 6 into 5 upon 2 into 1. This is 10 plus 15 equal to 25. N of A is 25. Next, what we need to find out now here? So that must be odd. Both are odd. Both are odd means only this case. Only this case. That means you can write here now. Let B be the event of getting odd numbers and sum, say that becomes say A intersection B. sum even. That means n of A intersection B is equal to, only this case you need to consider. Both are odd. Both are odd means here actually what you can take it now, 6C2. Am I correct now? 6C2. 6C2 equals to how much you have? That is 15. So we need to find out P of B conditioned on A. P of B conditioned on A means what is the formula? N of A intersection B upon N of A. So that means you can write N of A intersection B means 15 upon 25. 5 3 ja, 5 5 ja. So that will be 3 by 5. Second option is. So welcome back. Due to power cut, I was not able to continue the classes now. So it takes a time to rectify, to resume our classes. Okay. Could you please give me the question number? Everything is disappeared on the computer. I was not able to get back. What is the question number? Anybody? Vaishnavi, Suma, Vamshi. 42. 42. Okay. 42nd question. 42nd question. Because I didn't save the previous one. The sum of the two positive numbers is 10. The probability that their product is greater than 20. Greater than 20 is first option 1 upon 9, second option 4 upon 9, third option 5 upon 9, fourth option 19 upon 20. See, the sum of the two positive numbers is 10. 2 means actually your order pair you will getting. For example, let us say A comma B with the two numbers, A plus B is equal to 10. Next, probability that product is greater than 20. Their product must be greater than 20. So that means this problem can be done without using conditional probability also. Let us consider the number of favorable cases to get sum of the two positive numbers is 10 as n of s. Number of favorable cases to get the product greater than 20 is n of e. N of e by n of s, you get the answer. Okay. So now let us say like this. In general, you can do like this also. So I discuss one method here. Let A comma B be two numbers, two positive numbers such that A plus B is equal to 10. This is one condition. Next condition is that whose product is greater than AB is greater than 20. Say equation 2. With the help of these two, we need to find out A value or B values. Then we can solve it. This is one method. This is one method. So simple method I will explain. Let me explain simple method here. So what is the simple method means actually? Let us say S is equal to here 1 comma 9. 1 plus 9 is 10. 2 comma 8. 3 comma 7. 4 comma 6. Possible cases. 5 comma 5. And next 6 comma 4. 7 comma 3. 8 comma 2. And 9 comma 1. These are the possible cases. That's all you will be getting. Because 0 is not there. Only positive numbers. 1 comma 9, 8, 2 comma 8, 3 comma 7, 4 comma 6. The pair will be like this. Out of them product must be greater than 20. Greater than 20 means just you check it. Possible cases. 1 9 ja 9, 8 2 ja 16, 21. Yes, this we shall consider. 6 4 ja 24 greater than 20. 5 5 ja 25 greater than 20. 6 4 ja 7 3 ja. But these two are not allowed. 1 2 3 4 5 cases are possible cases, favorable cases. So that means actually here you write down E equals to 3 comma 7, 4 comma 6 and 5 comma 5, 6 comma 4 and 7 comma 3. So therefore now required probability P of E is equal to N of E upon N of S. 1 2 3 4 5 upon 1 2 3 4 5 6 7 8 9. 5 upon 9. That means third option is the right option. So otherwise, if you want to solve this one, B is equal to 10 minus A times 10 minus A is greater than 20. This is 10A minus A square greater than 20. Multiply with minus sign. A square minus 10A less than minus 20. A square minus 10A plus 20 less than 0. This inequation we need to solve. We get the A values. Interval you will get it. In that interval you need to find out. This will be possible cases is actually for A plus B is equal to 10. 9 possible cases. Here solution you get inequation solutions we get 5. 5 upon 9 will be the answer. This is the another method. This is actually adopted second method. This method is called second method. This is very easy approach because we have here limited number of sample space is countable, but everything is countable, but there are many more than some 20 30 40 50 means in that case we cannot do it. So this method is the best method. So this method we need to adopt. (43) P of A union B equals to 5 upon 6. P of A intersection B 1 upon 3 and P of B bar equals to 1 upon 2, then A comma B are first option independent, second dependent, third exclusive, Fourth, none. So here already A intersection B is defined, means this is it's not exclusive. P of A intersection B is equal to 0, then exclusive we can say. So either it may be independent or dependent. So that means for independent or dependent we have one test. What is the test means? If P of A intersection B is equal to P of A into P of B, then the events are independent, otherwise they are called dependent. That means we need to find out P of A intersection B already there. We need to find out P of A because P of B bar is there. P of A into P of B, we need to check that is equal to 1 by 3. Then we say that independent, otherwise dependent. So P of A union B equals to 5 upon 6. P of A intersection B is equal to 1 upon 3. P of B bar is equal to 1 by 2. P of B will be 1 by 2 only. Now solution. So P of A union B equals to, using addition theorem on probability, we can write P of A plus P of B minus P of A intersection B. This is 5 upon 6. P of A, P of B is also 1 by 2 because 1 minus 1 by 2 minus 1 upon 3. Multiply with 6, 5, 6 P of A, 6 into 1 by 2, 3, 6 into minus 6 into 1 by 3, 2. So this will be 6 P of A plus 1, 6 P of A equals to 4, P of A equals to 4 upon 6, 2 by 3. So now we need to check now. P of A into P of B. P of A is 2 upon 3 into P of B. P of B is 1 by 2. This will be 1 by 3. Absolutely 1 by 3 equal to P of A intersection B. Therefore, A comma B are independent. So first option is the right option. One dice and a coin are tossed simultaneously. The probability of getting 5 on the top of the dice and tail on the coin on the coin is first option 1 upon 2, second option 1 upon 12, third option 1 upon 6, fourth option 1 upon 8. This is the question. One dice and a coin are tossed simultaneously. The probability of getting 5 on the dice and getting a tail on the coin. So because actually remember, dice, rolling a dice and throwing a coin are the different events. They are independent events. So that means actually the probability of getting 5, that means event of getting 5 when a dice is rolled is, for example, A. The event of getting tail when a coin is tossed. B. A comma B both are actually here independent events. What we need to find out? Probability of getting 5 on the top of the dice, and symbol is there, and keyword is there. This is very important keyword. This is the keyword. That means A intersection B, P of A intersection B we need to find out. So that means solution, let A be the event of getting phi on top of dice. So therefore P of A, probability of getting 5 on top of dice, means when a dice is rolled, possible cases is 6. Out of 6, 5 means only one case probability, 1 by 6. Let B be the event of getting tail when a coin is tossed. That means therefore P of B is equal to, so tail is one chance, total 2 chances, 1 by 2. But what we need to find according to the problem, probability of getting 5 on the top of the dice and the symbol and tail on the coin. That means P of A intersection B we need to find out. But according to the problem, A comma B are independent. So P of A intersection B is equal to P of A times P of B. P of A is 1 by 6 times 1 by 2. Answer is 1 by 12 or 1 upon 12. Second option. Option 2 is the second option. Next, 45th question. 45th question. A coin and 6-faced dice both unbiased. Unbiased means there is no change. symmetrical, that means unbiased or thrown simultaneously. Simultaneously. The probability of getting a head, probability of getting a head on the coin and an odd number on the dice is first option 1 upon 2, second option 3 upon 4, third option 1 upon 4, fourth option 2 upon 3. 2 upon 3. A coin and a dice. Dice means has 6 faces only, obviously. Both unbiased are thrown simultaneously. The probability of getting a head on the coin and, keyword and, this is keyword, an odd number on the dice. So that means first how to make a plan. That plan we need to devise a plan. That is very important thing. So what is the plan means? First, probability of getting a head when a coin is tossed. That is 1 by 2 obviously. The probability of getting an odd number. Probability of getting an odd number means probability of getting 1, 3 or 5 when a dice is rolled. So that is 3 cases out of 6 cases. 3 by 6. That is 1 by 2. 1 by 2 into 1 by 2. Answer is 1 by 4. But without paper pen also we can do it just by seeing the problem itself only. But in order to visualize thing, I need to put on the paper. So look at the screen. Let A be the event of getting a head on the coin. That means P of A is equal to probability of getting head, 1 chance out of 2. Next, let B be the event of getting an odd number on the dice. That means P of B equals to P of getting 1 or 3 or 5 out of 6. 3 upon 6. 1 by 2. A comma B are independent. Therefore, P of A intersection B is equal to, because since they are independent, what do you write now? P of A times P of B. So that means 1 by 2 multiplied by 1 by 2. So 1 by 2 into 1 by 2 is equal to 1 upon 4. That means third option is the right option. Third option is the right option. Am I audible? Am I audible? Forty-sixth. 46th. If P of A equals to 1 upon 2, P of B equals to 1 upon 5, A comma A and B are independent events, then P of A after the occurrence of A union B, or P of A conditioned on A union B. First option 1 upon 6, second option 1 upon 2, third option 3 upon 4, fourth option 5 upon 6. This is the question. Right. Independent events means already here we have the very clear idea. So independent events means P of A intersection B is equal to P of A into P of B. Enough. Already P of A, P of B actually have been given. Okay, let us do it now. P of A equals to 1 upon 2. P of B equals to 1 upon 5. This is very important point in the problem. Independent events. So that's why now we need to find out P of A conditioned on A union B. Using the definition of the conditional probability, this can be written P of A upon or divided by P of A union B. But P of A is known. This can be written now P of A upon P of A union B is equal to, we can write P of A addition theorem plus P of B minus P of A intersection B. As this is the keyword we have independent events, this can be rewritten as P of A upon P of A plus P of B minus P of A into P of B. Simple. With the help of P of A and P of B, this can be evaluated. So let us evaluate it. Let us evaluate it. So 1 upon 2 upon 1 upon 2 plus 1 upon 5 minus 1 upon 2 into 1 upon 5, 1 upon 10. Multiply both numerator and denominator with 10. You get 5 upon 5 plus 1 minus 1. 5 upon, this is actually 2. 5 plus 2, 7 minus 1, 6. 5 upon 6. Fourth option. Option 4 is the right option. Forty-seven. A and B are two possible events of an experiment such that P of A equals to 0.3, P of A union B is equal to 0.8, and P of B equals to P. The value of P if A and B are independent is first option 2 upon 10, second 3 upon 10, third 2 upon 7, fourth 5 upon 7. Here A comma B are two possible events of the random experiment such that P of A is equal to 0.3, P of A union B is equal to 0.8, P of B is equal to P. Here keyword is, what is the keyword means here? A and B are independent events. That means P of A intersection B is equal to P of A into P of B. So now we need to find out P. So let us do it now. See, the P of A union B can be written as like this: P of A plus P of B minus P of A intersection B. You can work it out, this one. So both P of A union B we have, that is 0.8 we can write. P of A 0.3 plus P of B we do not know, P minus P of A intersection B, P of A into P of B. So this we can write 0.5 equal to P minus P of B is P, P of A is 0.3P. This will be 0.7P equal to 0.5. So now P equals to 0.5, 5 by 0.7. You get 5 by 7. So fourth option is the right option. Where is Pergu Ramya? She asked all these questions, but she is not there. She is not watching. Forty-eight. If A and B are two independent events such that P of A intersection B equal to 1 upon 6 and P of A intersection B complement equal to 1 by 3, then P of A equal to first option 3 upon 5, second 1 upon 2, third 1 upon 5, fourth 5 upon 6. Right. Now A comma B are two independent events. That means P of A intersection B is equal to P of A into P of B. Then P of A intersection B given, that means P of A into P of B we can find out P of A intersection B bar. So here one important concept you might have studied in IPE also. If A comma B are two independent events, their complementary events also independent. A bar, B bar, A dash, B dash also independent events. So that important thing we need to remember. A dash comma B dash are also independent provided A comma B are independent. Already provided they are independent events. So now let us do the solution. Let P of A equals to say X and P of B equals to Y. We need to find out X value. So from this we can write P of A into P of B equals to 1 by 6. That implies xy equals to 1 by 6. Say equation 1. So now this we can write P of A into P of B bar or B dash equal to 1 upon 3. This we can write P of A times P of B dash is equal to 1 minus P of B. This equal to 1 by 3. Now we can write x times 1 minus y equal to 1 upon 3. So this we can write x minus xy equal to 1 upon 3. So here xy is equal to how much? 1 by 6. Substitute here. Substituting x minus 1 by 6 equal to 1 by 3. We need x value. So therefore x equals to 1 by 3 plus 1 by 6. LCM is 6. 2 plus 1. That will be 3 upon 6, 1 by 2. This 1 by 2 is nothing but P of A. Second option is the right option. Second option is the right option. So generally all the viewers will watch, but they don't like it. But I do not know. But they will get the benefit from our classes. But they do not wish to even share the comments and etc. So simply they will watch and go. That's only. Because if you just like and share, subscribe, then we will do more videos. That depends upon your attitude. Because it's not a paid channel, I already told you, but I should not say, I should not repeat so many times that word, isn't it now? Only few people are, only the common people are few. Only countable people are giving their responses in the chat box. But all of you should give it. So that gives us a lot of encouragement to us to continue the classes through online. Understood now? I hope everybody will do that. Even offline viewers also, you need to give your feedback. As for the feedback, we shall continue the classes. See, for example, in the morning session, Perguramia asked me these type of questions. So immediately I changed my strategy and I started the problems on what she has asked, she requested, but she is not there now in the chat box. she might be left the class. So that should not be done. Okay, you need to encourage us. Okay, thank you. So we shall continue in the next session. Next session, some difficult questions. Next session onwards, we shall discuss some typical questions. Some typical questions on probability we shall discuss. Okay. Till then, goodbye. Thank you. Bye bye. See you.